Hello and welcome to this video where I'll show you something very unique and something that you're probably not going to use in a real application, but still it took me a lot of time to try to figure it out, and actually there's no documentation online for this, so hopefully I can help someone. Imagine having a Spring application with Spring data, but instead of specifying the connection properties in the properties file, you have the users providing their own connection to their own database and using it for their own purposes. And to make it even more interesting, the users can choose between multiple databases, in our case MySQL and Microsoft SQL Server. So in this video I'll walk through an application that I already built and I'll show you the key areas that actually allow this functionality to work. The code would be uploaded to GitHub, so you can actually go and check in more details for yourself. Before we go into the code, I'll make a short introduction to the app to see what it looks like and see how it works. So here it is. Actually, when you open the browser, the first page that you're going to see is this one, which is for connecting to the database. So here is where I can choose like my database connection that I'm going to use throughout the application. So let's try to connect to a database here. I'll choose MySQL, localhost, and intentionally I won't type a password to see. Actually, you get an error that you can't really connect to the database with those credentials. So if I add a password, you can see that I managed to log in. And this page here is for selecting which database to connect to. And as you can see, there are a few. Actually, those are exactly the ones that I have in my MySQL database. So if I just go and like try to connect to any one, it will say that the database is incompatible. And I'll actually show you how I managed to do that. But this one database is actually compatible with our application, so I'll choose it. And the next screen is, this is now part of the actual application, so I'll just have to log in here. And here it is. It's a very simple application. It actually doesn't really matter because the idea is to show you the multiple databases. But yeah, as you can see, we have a simple to-do list here. We can sort, we can filter, we can do pretty much everything. So I can even go ahead and add a task and complete it and stuff like that. So yeah, now what I can do is I can open an incognito window and open a new instance of the application. And as you can see here, if I refresh the page, actually I have still this connection like working for me fine. But here, because we are on a different session, this thing requires a connection to the database. So I'll go with SQL Server this time, enter in the credentials, connect. And here also I have to choose a database, and this one is compatible, so I'll go with that. I'll log in. And by the way, this login, they are the same usernames, but it's from a different database, so it's not like one and the same here. And as you can see, we loaded the app, and there are different tasks here. And if I go and let's say refresh the app, you can see that the data here is still for that database. And if I go here and if I refresh, you can see that this stays the same as well. And here on top, actually, we have the database that we actually connected to. So one more thing that we can do with this application is go create a new instance. Yeah, because it's the same session, I'll have to log out and I'll have to change the connection, or actually because we already have the connection, I can select database, but I wanted to show you the new database functionality. So basically, here I can create a new database from the application. So let's try pasting to do list. Let's add a new admin account like that and create the database. And actually, if we go to the SQL Management Studio, if I hit refresh, we should have the new database, and here it is actually. So yeah, let's try to see the users. You see that I just added the admin. So let's log in, and you can see we have a brand new to-do list. So works as expected. So basically, this is the idea of the application. As you can see, every session has its own connection to the database. I'm not sure how practical this thing is, but it's definitely something that you won't find described on the internet, and that's why I decided to make a tutorial about it. So with that being said, let's jump into the code and let's see how exactly this thing works. Let's start with the dependencies. So this is the POM file, and like the more important ones are Spring data, H2 database. I'll explain why we need that in a short while. Flyway, the MySQL driver, the Microsoft SQL database driver, and yeah, the other ones are pretty standard. So this is the properties file. As you can see, there's nothing here about database connection. There's only like few other settings that are used by the application. The package structure is the following. So we have the API package where it contains some other packages which are like functionalities splitted by their domain. So the database and the session is what we're going to look at here. Other than that, we have the configuration package with all the Spring configurations, and the web is where the controllers are located. The rest is unrelated for this example. Okay, so let's start with session actually, because I am using a custom logic for session management. So let me show you the session entity. We have a simple class here. So we have session ID, the last time this object was accessed. We have the session storage, which is a simple mapping of string and whatever object we want to store. Here we have the option to update the last time we accessed it, and we also have the possibility to invalidate a given session. Let's go to the session service to show you what we have here. So we have this map of session ID and session, and this is a concurrent hash map. We have a configuration which is for like how long can a session live, and this is set up here in the properties file. This is a simple cron job, or not even a cron job, it's more of a fixed interval, and it just goes through all sessions that are currently in place and checks like if they have expired, and if they have expired it removes them, and does some other things, such as if there's something in the session storage that is auto-closable, it closes it so that we don't get any leaks for that. And I'll explain that a bit later why we actually need that. So we have a method for generating the session, for getting the current session, and setting the current session. And how we actually set the current session. So let's start with the actual field here. So it's a thread local, which means that the value of this field is bound to the current thread. And with that being said, let's see, set current session. So we set that in a filter, and that filter is actually like the first of the filter chain. Let me just go back to the settings here. I added this Spring Security filter order to be 0. In that way, we can ensure that this filter will really be the first one that executes and ensures that we have our session set. And as far as the session goes, it's just a simple header for session. And if we have that, we try to set the session if it's valid. Just to give you an example here, let's see the network tab. And here it is, the session token. And what happens if I, for example, go to application and clean the cookies? By the way, the session is stored in the cookie, that's why we need to do that. And if I hit refresh, you can see I got an error saying like no session, and like basically this triggers the front end to try to establish to get a new session. As you can see here, we request the session and we started using that. So this is how the session storage works basically. So now let's move to the database, and there's no better way to start than this enum file, which is called database provider. And here I've tried to do it in a way that if we add another entry here, if we just implement those required fields, it should pretty much work across the board. So let's go through them. So this display name, this is actually what we get here on that drop-down menu. The default port, that's obviously the default port of the database. We have the driver, we have this connection util class. We have the folder in which we store the database migrations, and this is here. If we check it out, migrations, we have the ones for SQL Server and the ones for MySQL. The idea here is that the first one should always be v1 init, and the rest of the files doesn't really matter. The names of the files, they shouldn't be, there's no need to be the same, but the first one should be init, and I'll go into that a bit later. And the final one is the specific dialect for that database provider. That's really important, and this is pretty much one of the things that caused a lot of problem for me. So let's go to those connection utils. This is a class, as you can see it even here. It's an contract or interface which has those functionalities. So we have the option to create a connection string, to find all databases, to check if the we have a valid Flyway table, and this is for checking if the database is compatible, and this is the logic for creating a database. So find all databases is what we get here. Yeah, so this is the find database operation. So let's go into that and see it. As you can see, we have like two implementations. So let's see the one for MySQL, for example. And yeah, it's a simple execution of a query, but on that level, we haven't been connected with the ORM yet, so we need to execute the native query. That's why we actually need this util. So yeah, overall, those classes, like each method here, is using native queries, as you can see, and that's like before we have established the connection to the database. So this one for the Flyway, for example, as you can see, it's checking the script here, it's comparing the names and stuff like that, and making sure that the files are valid. And as I said, the first one has to be called init.sql in order to be considered as a compatible database. Obviously, that's not the only way we verify the database. There are a few other steps. We'll go into that as well. So let's check this database service. Actually, before that, we should probably check this database class. So this class is stored in the session storage. As you can see, it implements the auto-causable interface, and it's required because we store here two data sources, JDBC data source and ORM data source. So what's the idea here? The JDBC data source is something that we use on this level while we're like connecting with Spring Data. And after we've connected to Spring Data, we actually close this and we start working with the ORM data source. Pretty much they're like pretty much the same, with the exception that when we're working with JDBC data source, we haven't specified which schema we want to use or like which database we want to use, and here we have specified that. So here we have the option to close those, and yeah, that's pretty much. As far as for the other properties, here we have this database provider here. So let me go back. Yeah. We have the connection properties. So those this is what we use to connect to the database. We have the data source config, which they are pretty similar in terms of what data they store, but this one stores the password as well. We have the selected database, and this is actually what we have selected here on this page. And yeah, that's pretty much for this class. Let's go to the database service and see what we have here. Okay, so let's check this method out and see, because I think it's a great example. So the front end sends this database connect DTO, which has like the provider, host port, username, password, and if you want to use SSL or not. And what we do here is we get the current database, and let me just show you how we achieve that. So we get the current session. If there's no session, we throw no session exception, and if we just go into that exception, you see that that no session message that we saw on the front end a few minutes ago. So if we have session, we get the session storage, and from there we get the database session. Sorry, not the database session, but the database object for that specific session. Let's go back to this method. So yeah, when we connect to the database, we clear the old connections. We set up the properties here, and here's where we try to like connect to the database. If we have like an exception, we're going to throw it, and as you saw earlier, we actually display that on the front end. So yeah, this is pretty much how we connect to the SQL Server. For like the selection of database, well, here is where we actually like do the validation. So that's probably going to be interesting for you. So similar thing, we get the database. If there's no connection, which basically what this method does is checks like for JDBC or ORM connection. So let's go back here. We throw an error as well. So here is like we get all databases and check like the provided database in the payload, if it's a valid one or if it's not. So if it's not, we're going to throw an error here. Next is changing the JDBC URL. So now we create a new URL, but this time we use the selected database. So we then try to create the new data source, which is now called the ORM data source because it has the selected database in that case. Here we check like for this Flyway validation, and if it's not valid, we close the data source and we throw an error. And here is where we execute the Flyway migrations, and this is basically the second way we make sure that this database is valid, because the first time we only compared the names of the files, but now we use actually Flyway to actually do a proper migration. And as you probably know, Flyway also checks the checksum of the files, so it's a guaranteed way to validate databases. And yeah, that's pretty much it. Then we set the ORM data source to the database object, and we're pretty much good to go with that. What is left to do now is like Spring to know that we have ORM data source in that database object and like make use of it. And how exactly it does that? I would say the most interesting part of the video. Let's go to the configurations package, database, entity manager config. So click here. Okay, so let's start from top. The things that we depend on is the database service. This is just a flag indicating whether the application has loaded or not. We have just a simple event here, and like when this happens, we set the flag that the application has started. So let's go to the first bin here. I've even added some description just to be clear. So for the data source bin, we use a class called routing data sources. We supply it with the database service and a default data source. And this default data source is H2 data source. That's why we need it, but let's see exactly here why. So this routing data source extends a class coming from Spring. It's called abstract routing data source, and it has one method called determine lookup key, and this other one determine target data source. In that case, we have overridden this one, and here basically whenever Spring is going to like execute a query, it's gonna come to that method asking for the data source. And what we can do here is we can like supply it with some, let's say, logic to like know which data source to give to Spring data. So as you can see, the check here if the app has not loaded yet, give it the default data source. That's needed because otherwise Spring will not start, because during the startup of the application, Spring data is really reliant on, like, it's not really designed in a way that it expects you to not specify database credentials. That's why I decided to create this workaround, basically giving it the H2 database while it's loading, just to have something there. And then if the app is not loading, we use the database service, get current ORM data source, and let's go into the implementation of that to see what exactly we're doing. So we're getting the database using this same functionality, and here if there is no ORM data source, we just throw no database connection exception, and the front end then does its thing and redirects us to the connection page. Okay, let's go back. So this is the routing data source. So we create a bean for that. And then the second bean is for entity manager factory. Here we require this newly created routing data source as a parameter. And what we do here, let's start with this map of database provider and entity manager factory first. So database provider, it is this enum, the entity manager factory, obviously the required class. And then for each provider, we create an entity manager factory. And this is very important because otherwise there's a problem where, let's say, we go to that routing data source and we want we supply it with the Microsoft SQL Server data source, but the default entity manager factory has been set up to work with MySQL, and this causes a problem with the dialect, and basically the queries will fail. That's why we want to have for each database provider to have their specific entity manager factory. So what we do here is just a standard build for that specific class for the entity manager factory. The interesting thing here is this packages to scan and the dialect. So the dialect is the one coming from the database provider, and for specific provider we have specific dialect, and this package base package name is actually this one. This is the startup class, and I chose it to be the base package because it's on the top level, and choosing this will actually make the application run faster, because instead you can just write here something like com, but that's really performance heavy, so I suggest using the shortest, the longest possible package. We set the data source here, and I guess that's pretty much for this method. There's nothing much more interesting. Next, we create a default entity manager factory, and the reason behind this is similar to the data source. We also really need one entity manager factory while the application is loading, so we create one with H2 dialect. And next, and finally, this is probably the thing that took me a long time to come up with this idea, but now that I look at it, it's pretty simple actually. So instead of returning any of those entity manager factories, what I do here is I return a proxy of entity manager factory, and in the handle here, I decide which instance to use based on the similar logic to the routing data source. So by default, the default entity manager factory is used, so the one with the H2 database connection, H2 database dialect, I'm sorry. And here we again check the database service to get the current database provider, and the logic here is really similar to the data source, so I won't go into details. But if there is such, we get the instance that is specifically for that dialect, for that database provider, and we use it. And finally, we use the proper instance to invoke a given method. And that basically ensures us that when we're whatever data source or whoever uses this, it's going to be guaranteed that he's going to receive the proper dialect and the proper data source. This is it for this video. Unfortunately, I couldn't write code in this one because the actual logic for the routing databases is not really not too much to write, but in order to test it properly, I would have to write a whole application, just like I did with the to-do list. So I guess that would be a lot of waste of time for you guys. So that's why I just went with the overall like overview of the code. Hopefully that's still helpful to you. And if you want to check it in more details, you can go to the GitHub repository. As you can see, I even uploaded the front end. So if you're interested in that, you can also go and check it out. And yeah, with that being said, thank you for watching. Like and subscribe if you enjoy unique and interesting problems like that, because I definitely plan on making similar content in the future. So yeah, thank you for watching, and hopefully I'll see you next time.